Access Minnesota. Issues that matter to you. Access Minnesota brings you the newsmakers and the stories that shape our everyday lives, with analysis from University of Minnesota faculty experts. Now, here's Jim Dubois.
This fall semester, the University of Minnesota launched the Grand Challenge curriculum. Courses taught by cross-disciplinary instructors pull together the vast resources at the university and aim to address the world's most pressing issues. The 5 courses starting the Grand Challenge curriculum tackle problems of hunger, health, war, and energy sources. This month on Access Minnesota, we sit down with 2 professors teaching a Grand Challenge course. Professors David Tillman and Jason Hill titled their course, "Can We Feed the World Without Destroying It?" We'll discuss how a Grand Challenge course is different from other classes at the U and how students are addressing many complex issues surrounding the global food supply. David Tillman is Regents Professor and McKnight Presidential Chair in Ecology at the University of Minnesota. Jason Hill is an Associate Professor in the Department of Bioproducts and Biosystems Engineering, also at the University of Minnesota. This semester, they have teamed up to teach one of the U of M's new Grand Challenges courses. Their course is titled, "Can We Feed the World Without Destroying It?" Professors, welcome to Access Minnesota.
Thank you.
Thanks for having us.
First of all, tell us more about the purpose behind the Grand Challenges courses and how specifically does your course fit into the overall program?
The Grand Challenge curriculum was posed as a way to let students very early in their career at Minnesota know what the big unanswered questions were across many, many different disciplines. The goal was to let students, by learning of these big challenges that face society and science, decide what they might want to do earlier in their career. So the goal is to excite them with questions that are not yet answered, to let them understand the process of inquiry, and to let that maybe spark what they'll decide to spend their life on.
Tell us about your academic backgrounds and research here at the University of Minnesota.
Well, my PhD is in zoology, but as strange as it sounds, I've always studied plants. And I've been very interested in the ways that organisms interact with each other and how that determines the functioning, stability, productivity of ecosystems. And along the way, I became very interested in agriculture because agriculture not only is how we provide food for all of the world, but it also turns out to be one of the most significant environmental impacts that humans have. Agriculture and fossil fuel combustion are the 2 big things we do that have environmental harm, but we need both of them. So I became intrigued by them, as did Jason, about the same time, because we saw these were big challenges facing the world, and we wanted to find solutions.
So my background is also in biology, plant biology, and I became very interested in these issues related to the environmental effects of agriculture from an early age. In fact, grew up on a farm and got to see some of the effects of our own farming practices on the environment at that time. Over the course of my career, I moved into this area of understanding the environmental impacts of the decisions that we make, focusing largely on agriculture and transportation.
What is different about the structure of a Grand Challenges course versus other classes taught at the University of Minnesota?
Probably the biggest thing that I notice compared to the traditional disciplinary courses that we teach is that we're tackling a question. And in particular, this semester we're looking at this question of, can we feed the world without destroying it? And everything we do in this class is designed to help students answer that question for themselves. So all of our readings, activities, lectures, interactions that we have are focused specifically on getting to that one point.
Could you tell us about some of the activities you've had the students do in the class?
So one of the activities is they've written a policy brief. They've taken on some issue that they think is important to solving this grand challenge. For instance, closing yield gaps or changing diets, and are advocating some sort of global solution to that challenge. But they're also doing what we call the knowledge to impact segment, where every week we spend about an hour having them work in groups to come up with some sort of solution that could perhaps be implemented with a little bit of funding, maybe $2,000 to $3,000, something that could help either educate other people or provide them with some sort of product that could help them improve their own diets, or how they grow food, or how they get food from one place to another. So we're having them look globally at this problem, as well as very locally in terms of solutions that could build up to a global solution.
Tell us more about the students who are taking the class. Is there more diversity among the students' backgrounds and areas of studies than you might find in a typical course?
So the students taking this course are from all over the university. They represent colleges on all three of the Twin Cities campuses. They're at every level, from first years all the way through seniors, and they have interests that are as diverse as the majors that they come from. And so they're each bringing something from what they already know and what they're already learning in their major, and bringing that together on this question, because this question of can we feed the world without destroying it is at the intersection of economics, the environment, public health, et cetera, et cetera.
The course is titled, Can We Feed the World Without Destroying It? What are the threats to the global food supply, and how dire is the situation?
The global supply of food doubled in about the last 45 or so years in response to the Green Revolution. And that was very important because there was concern in the 60s that we might have massive global famine and starvation. And so to a great extent that has been avoided. But what we see now is that we're in need of doubling it again, not because we're going to have twice as many people, but because human diets are changing. And what else we've learned from the Green Revolution, the wonderful impact of doubling global food has been of massive importance. And Borlaug, who got this going, won a Nobel Peace Prize for it.
Norman Borlaug.
Norman Borlaug, and he was very deserving of that Peace Prize. And what we've learned since then is that there are lots of unintended consequences of how we've doubled global food. So agriculture releases not quite a third of all the greenhouse gases on Earth. Most people don't think of that. They think about cars and airplanes being the big culprits, but in fact, agriculture releases twice as much as they do. Massive amount of land had to be cleared to grow crops and to have pasture land for livestock and so on, and that has its environmental impacts. And the fertilizer, which really led the Green Revolution, doesn't, if it's not used well, a lot of it escapes farmers' fields and enters the groundwater, lakes, rivers, streams, and the ocean. So all these unintended consequences. And so it is a challenge asking whether we can feed the world and save the earth, if you will. That is really a challenge. Even on the can we feed it side, doubling production again might expose us to some instabilities in the global food system. We get most of our food from only 3 crops, corn, wheat, and rice. And as those become more and more common on Earth, they're also going to be more and more susceptible to newly emerging diseases. We've lost the chestnut tree, we lost the elm tree in North America to disease. And one of my concerns is I would like to see people fed for not just the next 10 years or 50 years, but the next 100 years, the next 1,000 years, the next 10,000 years. And what is the chance we can keep our crops free of really fatal diseases for that period of time? Or do we need to diversify how we grow food? So there are issues like that.
Which specific food production practices do you consider to be unsustainable?
Sustainable is a word that is hard to rigorously define, but I would say there are practices that we have that are much less sustainable than they could be and should be. For instance, it is common in modern high-intensity agriculture to apply all the fertilizer at the beginning of the growing season. But the plants aren't doing their greatest uptake until the middle or so of the growing season, and so there's loss of that nutrient that isn't being taken up by plants. It's being carried by water, groundwater, and so on into lakes, rivers, streams, the ocean. So that is a really unsustainable way to be applying fertilizer. We also have unsustainable ways that we use pesticides. We often use too much pesticide and use it at the wrong times. So there are ways that we know to apply the right amount of fertilizer at the right time. There are ways that we know to minimize the use of pesticides, both of which can be very important. And there are ways that we know to plow fields and to have buffer strips of vegetation that can help keep lakes, rivers, and streams much cleaner. Those are the practices we need to employ more fully if we want to have a more sustainable approach to agriculture. So I'm not going to say one crop is unsustainable, some other one is sustainable. It's not that simple. It's really what are the best practices. We need a diversity of crops. And what are the best practices for each crop in each region? that if we follow them, we can minimize the environmental impact of agriculture while still providing the world with the food that we need.
When Access Minnesota continues, we'll look at whether healthy eating and diet trends conflict with food sustainability.
Access Minnesota will return after these messages. You're watching Access Minnesota. Here's Jim Dubois.
Now back to our conversation with Professors David Tillman and Jason Hill on the many complex issues surrounding the future of food sustainability. There's a greater consciousness today about where our food comes from. Many consumers want locally sourced products, organics, cruelty-free or cage-free meats. Are these practices consistent with growing demand and environmental threats? In other words, if we try and make use of more locally sourced products, if we avoid meat that's produced in animals confined in cages or under cruel conditions, is that actually doable from an economic standpoint?
Yeah, so those are many different things. So you're asking about all sorts of different reasons people might prefer to choose one food over another. Cage-free, organic, local. I mean, these are all sorts of gluten-free, for instance, right? And we want the perfect food, the one that's healthy for us, that comes at no environmental impact, that provides workers with sustainable means of living and so forth. But what we have to do is look at the full life cycle of production and use of these different food options. We need to look at everything from what the effects are from growing them and producing the inputs that go into their production, to processing them, to transporting them to our tables, and ultimately where they end up in disposal. And when you look at all that, you have sometimes very non-intuitive results. In fact, local diets in some cases, like say take a tomato grown in a greenhouse in the middle of winter in Minnesota, might be much higher in terms of its carbon impact and essentially its effect on climate change than a tomato grown in California that's flown in or shipped by truck or rail. And that's because, well, it's cold in Minnesota at the time and you have to heat that greenhouse. So it's not as simple as just eating local or any one of these other buzzwords about a diet. You need to look very carefully at what happens overall to bring that food to your table.
How can we encourage greater biodiversity?
So biodiversity happens on many different scales when it comes to agriculture. We have diversity within the crops themselves, so we have different cultivars or germplasm it's often called, different traits within, say, corn or wheat that can be used in different climates under different times or to give us different traits like color or disease resistance. But there's also diversity in cropping systems. You can plant crops like continuous corn, that's corn year after year on the same plot of land, or you can plant corn one year and soybeans the next and oats the next, and you can get some benefits when you rotate crops like that, breaking up the weed cycles and the pest cycles. But there's also diversity in terms of overall landscapes. So rather than having a whole Minnesota agricultural landscape that's corn and soy, you can plant other crops over that whole landscape. And then there's biodiversity in the other species that live alongside the crops we want. A lot of weed species are actually hosts to insects and support a wide range of bird life and amphibian life and reptile life that goes along with that. So when you talk about biodiversity, it's happening everything from within the crops themselves to the overall ecosystem that agricultural landscapes support.
And if I could add to that, there's another feature of crop diversity which is used much more in less developed nations, which might have some applicability to the U.S. and other richer nations. That is something called intercropping. It's where you plant two different types of crops sort of in alternate rows across a field. And for instance, this has been shown in China for two varieties of rice, one of which is very susceptible to a fungus and one of which is not. That by planting the one that's susceptible to a fungus every other row, it makes that plant to be at a low enough density that the fungal disease can't live in that field anymore. It's just there aren't enough of the susceptible plants around to have it make it. And so by doing this, farmers are able to go from having to apply lots of an expensive and also harmful for human health and harmful for the environment fungicide to that crop to being able to just grow it every other row. And by doing that, get rid of the need for the fungicide, the cost and the human cost and the environmental cost. You can also grow 2 different crops, one row and the next. So instead of corn one year and soybeans the next, you can have corn with some legume next to it every other row. And if you have a legume that grows best early in the year, it won't be casting much shade on the corn. The corn will be able to get taller of it, grow later in the growing season, and be able to take over the place where that plant had been rooted and take up some of the nitrogen it had fixed. But legumes, also turns out, are good at getting phosphorus from the soil that corn can't get, so it can provide phosphorus to it. Now, this kind of work a lot of this has been done on the research side in China. And a recent review of hundreds of studies showed that on average in China, the people who use intercropping get about 15% more total food from an acre of ground than if they don't. That's not a lot, but still 15% more is a lot more possible profit for a farmer, as well as a lot more food from a piece of land to society. And that could mean that we will have 15% less land we'd have to clear around the world to meet growing demand for food. So it's a small sort of niche thing, 15%, but still it's a 15% we could pass by. And there's one more thing I want to mention about biodiversity, and that has to do with animals and so on. Right now, for instance, in chickens, there are 7 companies that provide almost all the eggs that are hatched and grown into chickens around the world. And we saw in Minnesota a recent tragedy when a viral disease got into big chicken operations and caused them to lose hundreds of thousands of chickens in a single operation. I don't know if this would work or not, but we know for other things that having a high diversity of genotypes within a population often can reduce its susceptibility to disease. So it could be, but it has not yet been tested, but it could be that if we had more variety of chicken genetics within a single chicken coop instead of having one single variety from one producer in that chicken facility, that we might be able to have much less a rapid spread of disease, and maybe enough that the disease couldn't spread, just like with the rice issue in China. So I think that we're just learning how to use genetic diversity in new ways in agriculture, and in fact we might find there's a lot more need for genetic biodiversity than we ever had imagined when we go to high intensity agricultural production practices.
As home to one of the world's largest food producers, General Mills, Minnesota is in a unique position to address threats to the food supply and encourage more sustainable practices. When Access Minnesota continues, more on Minnesota's role in the future of the global food supply.
Access Minnesota will return after these messages. You're watching Access Minnesota. Here's Jim Dubois.
Here's more of our conversation with Professors David Tillman and Jason Hill on the new class they are teaching this semester at the University of Minnesota. Can we feed the world without destroying it? Is Minnesota, a strong agricultural state, home to General Mills, Cargill, uniquely positioned to address the issue of food supply?
I think Cargill, General Mills, Mosaic, some of the companies we have in the Twin Cities that are major international players in agriculture and agriculture production are a major resource for the state and for the world because they have a chance to take new ideas, develop them, and have them spread. Basically, nothing gets done unless it has global buy-in, and global buy-in normally means literally buy-in. So I'm delighted that we have these world-class agribusinesses in the state, and I think that they have lots of creative scientists who I know at these various companies who, if things go well, will be able to find ways to help solve the problems that we face. At the same time, they find a way to make money from it. And I think that really is a way we're going to solve problems. I tell my students when I teach on these issues, I said, you'll make me totally happy if you find a way to become filthy rich, saving the world and feeding the world. And I think that's really what it's going to take. And I do think we have amazing talent at those companies, and a lot of the talent came through the university, but it comes from other places too, that can go forward and attack these grand challenges and find some way, a solution, and a real solution has to be one that's viable for everybody. The food companies have to make money, the farmers have to make money, consumers have to be better off and happy, and I think they can find the ways to do it.
What are some of the solutions to the threats to our food system that you are tackling in this course?
So we actually have 5 areas that we're looking at, and I'm not sure I can name all 5 now, but the students are taking on these 5 areas and trying to propose answers to them, or at least bite off a little bit of the problem and try to tackle that. They're looking at increasing biodiversity in agricultural systems. They're looking at improving diets. They're looking at closing yield gaps, that is essentially getting more from each acre of land that we plant. They're looking at microfinance and ways of supporting infrastructure in rural systems. So all of these are parts of the puzzle that need to come together in order to have a more sustainable food system.
And if I look at what's been done outside of the classroom, outside of what we're teaching and trying to help the students think about and grapple with, there have been many analyses to show that the very items that Jason just listed, increasing yields, changing to healthier diets and so on, in fact, can really solve these problems. These are approaches which, if applied at a global scale, can greatly reduce or eliminate the need for clearing more land to feed people. Right now, we might be headed toward clearing 500,000 hectares of land, which is what, 1.5 million acres of land, or even more around the world to provide the food people need. But if we can bring these low-yielding lands in a variety of the poor nations up to their yield potential, we need to clear almost no new land. And if diets changed in a way that were healthier for people, again, we would greatly decrease the need to clear land. And these both would decrease greenhouse gas releases and so on. So some of the really big problems that the world faces as we try to feed people, there are paths to decrease or in fact even eliminate those problems and still provide the world of 9 billion, maybe heading toward 11 billion people with nutritious, healthy diets.
I just want to add to that it's not just work that needs to be done in the least developed and developing nations, but there's plenty that we can do here at home to improve our food system. For instance, here in Minnesota, on average, at the universities are getting yields that are about 30 to 40% higher than farmers do in the same counties. And why is that? It's because the universities have knowledge in terms of how to grow these crops that not all farmers are taking advantage of. So there's a lot we can do even here at home to improve our global food system.
Are your students optimistic or pessimistic that we'll be able to solve this particular grand challenge?
So we asked them this question on the first day of class. We have them fill out a sheet that asks the question, can we feed the world without destroying it? And I'd say about half the students are very positive and think we'll be able to do it, and half are much more skeptical that this will actually happen. We'll poll them again at the end of the year in a few weeks from now and see where they fall. But it's a very open-ended question. What does it really mean to feed the world, or what does it really mean to destroy the world? And so they certainly can see that depending on how you define those parts of the questions, you might take the answer one way and you might take it the other.
Well, I think we say, what can we feed the world without destroying it? And the real question might be, will we? I think the students by the end of this class will know that we can do it. The issue is, will these solutions be adopted around the world at a rate that can actually allow us to first feed the people who really are, 9 billion people are going to need food. And right now we have almost 1 billion people who have massively inadequate diets and suffer from malnutrition and so on, because they're not getting the food. Even though it is being produced, it doesn't get to them. They can't afford it and so on. So can we or will we? To me, that's the question.
David Tillman is Regents Professor and McKnight Presidential Chair in Ecology at the University of Minnesota. Jason Hill is an Associate Professor in the Department of Bioproducts and Biosystems Engineering, also at the University of Minnesota. Professors, thank you so much for joining us on Access Minnesota.
Been our pleasure. Thank you.
Thank you.
That's all for this month's edition of Access Minnesota. We'll see you again next month. Thanks for watching.
Access Minnesota. Issues that matter to you. Join us again next week as we bring you the newsmakers and stories that shape our everyday lives. Access Minnesota is produced by the Minnesota Broadcasters Association in cooperation with the University of Minnesota's College of Liberal Arts.